limit as z goes to 1 of 1 over 2z plus 2 minus 1 over z squared plus 3z, the entire thing over 2z squared plus 3z minus 5. The first thing we're going to do is try plugging a 1 in for each of the z's. So in the numerator we'll have 1 over 2 times 1 plus 2 minus 1 over 1 squared plus 3 times 1. And then all of that over 2 times 1 squared plus 3 times 1 minus 5. In the numerator we have 1 over 2 times 1, which is 2, plus 2, minus 1 over 1 squared, which is 1, plus 3 times 1, which is 3, all over 2 times 1 squared, which is 2, plus 3 times 1, which is 3, minus 5. In the numerator, we have 1 over 2 plus 2, which is a 4, minus 1 over 1 plus 3, which is also a 4. All of that over 2 plus 3, which is a 5, minus a 5. In the numerator, 1 over 4 minus 1 over 4 is a 0. In the denominator, 5 minus 5 is also a 0. We have the 0 over 0 indeterminate form. We will need to rework this. Since we have fractions, specifically right here, we will need to get the common denominator between those fractions. Now the denominator in the first fraction is 2z plus 2, or 2 times z plus 1 if you factor the 2 out. The other one is z squared plus 3z, or z times z plus 3. And therefore the only common denominator is 2z plus 2 times z squared plus 3z. There's nothing smaller than that. So we will have limit as z goes to 1 of 1 over 2z plus 2, and we're going to multiply this by z squared plus 3z over itself, a form of 1, such that we'll make the common denominator there, minus 1 over z squared plus 3z. We're going to multiply this one times 2z plus 2 over 2z plus 2, a form of 1 as well, to get the common denominator. And then this entire thing is over 2z squared plus 3z minus 5. We're not going to do anything with that since that is not fractions. We're going to just work with common denominators for now. So with the common denominator type, you will want to multiply the numerators of each of those fractions. 1 times z squared plus 3z is just c squared plus 3z over the common denominator of 2z plus 2 times z squared plus 3z. And then we will have this minus, the other fraction will be 1 times 2z plus 2, which will be 2z plus 2, over that same common denominator, 2z plus 2 times z squared plus 3z. And then all of this over 2z squared plus 3z minus 5. The next thing we're going to do is add those two fractions together now that we've produced the common denominator between them. So we will be able to subtract them. Be careful with this minus sign. This will distribute on both of those terms in the numerator. Just watch for that. That will give us z squared plus 3z minus a 2z and minus a 2. All of that over the 2z plus 2 and the z squared plus 3z. Notice I'm not distributing out. I'm keeping the denominator factored. You only want to distribute in the numerator when you combine fractions by addition or subtraction, because you have to add or subtract the numerators with each other, so you don't want them factored at first, and then you can refactor them later. And then all of this is over 2z squared plus 3z minus 5. I have some like terms I can combine together in the numerator, so I'm going to do that next. Specifically these two, a positive 3z and a minus 2z, that'll combine together to be a positive 1z, so we'll have z squared plus z minus a 2 all over 2z plus 2, z squared plus 3z, and then all of that over 2z squared plus 3z minus 5. We're going to now reciprocate the denominator. It's not a fraction, but I'm putting it over 1 so that it becomes a fraction, so that I can now reciprocate and multiply the denominator fraction with the numerator fraction. So z squared plus z minus 2 over 2z plus 2 times z squared plus 3z, multiplying with the reciprocal, which would then be 1 in the numerator, and 2z squared plus 3z minus 5 in the denominator. We can now multiply those out. We will have limit as z goes to 1. Multiplying the numerator, we have z squared plus z minus 2 times 1. So all that just stays the same. In the denominator, we don't want to FOIL anything. Keep this all factored. 2z plus 2, z squared plus 3z, and then 2z squared plus 3z minus 5. Now we have 0 over 0 here, and we haven't eliminated that just yet. That doesn't happen until we actually factor and cancel. And since z is going to 1, I would expect a z minus 1, or maybe a 1 minus z factor in the numerator and denominator. I'm not seeing that just yet. So it's contained within that quadratic there in the denominator and that quadratic there in the numerator. We're going to factor those. And that's going to be our next step. So we have limit as z goes to 1 of trinomial factoring the numerator quadratic. Two numbers that multiply to be a negative 2 but add to be a positive 1. It sounds like we want a plus 2 and a minus 1. There's the z minus 1 is expected in the numerator. In the denominator, 2z plus 2, z squared plus 3z. Here we're going to factor this trinomial quadratic. Since it's 2z squared, we're going to need a 2z and a z. We need two numbers that multiply to be a negative 5. Well, that can only be 5 and 1, and one of them has to be a negative. And then they will combine to get a positive 3, where one of them is going to get multiplied by that 2z. So I have a 5 and a 1. It sounds like I'm going to want the 5 here and the 1 here, so that I have a 5z here and a 2z here. 5z minus 2z will give us a positive 3z. So I'm going to want a minus there and a plus here. And there's the other z minus 1 factor as expected. So it's just something that you can kind of predict and expect to see that. And we are seeing that in the numerator and denominator. That's going to be what was making 0 over 0. And it can now be canceled, which means that we can now rewrite the limit, and we should be able to just plug the z value of 1 in for all of the z's that are left. There's quite a few of them right now, but once we plug that 1 in, things will start to simplify a good bit here. So I'm rewriting everything that's left over after having canceled out the z minus 1. So now plugging in a 1 for each of the z's. In the numerator we have a 1 plus 2. In the denominator we have a 2 times 1 plus 2. We have a 1 squared plus 3 times 1. And then we have a 2 times 1 plus 5. In the numerator, we're going to have 1 plus 2, which is just a 3. In the denominator, 2 times 1 is 2, plus a 2, times the quantity of 1 squared, which is a 1, plus 3 times 1, which is a 3. And then times 2 times 1, which is a 2, plus a 5. So that's giving us 3 over 4 times 4 times 7. 4 times 4 is 16 times 7 is 112. I will have 3 over 112.